Awesome. Very well. So yeah, welcome everyone. Welcome Sina. Thank you so much for joining us today. It's week 17. We have another office hours with a special guest today, joined by Sina from Go Ethereum. Over the years, we had a couple of Get devs. We had Marius here, Felix, and Matt. But first time we are joined by Sina. So that's our Get dev. Chosen for this cohort AMA. Thank you so much for being here. And um, of course, it's a couple more people now. Awesome. Thanks so much for joining, everyone. Before we get to the questions from the audience, having some chat with Sina, I would like to get some more context about you, some more about your background. So please tell us what brought you to Ethereum. How have you started in the core development, working in EF, working on the protocol? What you've done
Yeah,
before? Yeah.
sure. So first, hey guys, it's a pleasure to be here. Thanks for inviting Mario. Very nice to talk to you all, fellows. My story goes back a few years. So just for context, I have been working at the EF on Ethereum for 6, 7 years now. Um, been at Go Ethereum for a couple of years. Before that, I've been working on EWASM, and the first project that I worked was Ethereum JS. And that's actually how I got into working on Ethereum. Um, it was that, so I was, I guess, 2019, 18, 19, I was doing my master's thesis. And well, I had a lot of time on my hand. I didn't have any lectures anymore. And it was around the bull market of that time. And started looking into this because I had been hearing about crypto Bitcoin for a long time. And I decided to just learn a bit more about it. First, I went a bit into some of the less valid projects, less legitimate, and then found my way to Ethereum. Well, yeah, but on the way, it's funny because I started working on what was later named Nano project. They were claiming that, we have free transactions. I was like, wow, that sounds great. Who doesn't want free transaction? All these other blockchains, they're paid. You have to pay to use them. And I started using it, and it was like always in the back of my mind. But isn't it possible to DOS the network with this? And yeah, at some point, like I made some contribution, and at some point was asking them all these questions, like, okay, what about DOS? What about DOS? They um, they did a test net and said like, yeah, we will test this now, and started spamming the network, and of course the network went down, and then I was like, okay, there's a reason why you have to pay for gas for transactions. Anyway, so that led me to Ethereum, and like immediately I was shocked at how, I don't know, beautiful the protocol is, I guess. um, it was very nice. It was clear from the get-go that people here really know their game. They have a vision, and there's a lot of like technical richness here and a lot of interesting things to discover. So I, yeah, started dabbling a bit, uh, and it's fun because it's been 7 years. I, like, in my later years now, I have all this experience, and I, like, very rarely do I post something on ETH Research. And at the time, I didn't know anything, and I was just, as a new person, I just started posting on ETH Research for some reason, just anything that I was finding out, and like, I don't know, somehow it was, the community was very welcoming. Um, and I discovered at the time Gitcoin, which was a project, like it was a bit of a different iteration of Gitcoin. So they assigned bounties to GitHub issues. So you could solve a ticket or issue, and you would get paid for it. And me as a student who didn't have a lot of money, it was like obviously very excited by this. So I did one for Gnosis Safe and one for Ethereum JS. And um, I mean, so like the Ethereum JS team, they liked my work and they invited me to contribute. And so yeah, this is basically how I joined. And I've had a bit of a journey through Ethereum and um, through the EF, but yeah, now I'm here.
Very well, yeah. Thank you so much, Sina. Yeah, it's been. I mean, it's been a quite a journey because a lot of things changed in the protocol and over the past couple of years. So the first time I met you, like 5 years ago, you still been in the Vazen team.
Yeah.
So what I'm curious about is maybe more if you can elaborate on this, like what was the like, or how do you, the retrospective, like how do you see these efforts before the Epsilon happened, before the focus on the Vazem, and what was like your transformation to get, like actually how did you get into to the team, and what was it like to change from that? Yeah.
Yeah, I mean, for me, it was like from the beginning, since I joined Ethereum JS, I was like, it was always on my radar, and I found it so interesting. And I um, basically I had it from the get go that uh, when I talked to Holger, the team leader of Ethereum JS, I told him like I want to dedicate some of my time to EWASM from the beginning, and so this was the arrangement that we had. And I started looking into it, and at some point, like, then fully transitioned because like in Ethereum JS, there was a time when um, basically there was a time when I was the only person working on it, and I was like, as a new person in this company, I was feeling somewhat lonely. I felt like I needed mentors. I was doing like it was going great, but I just felt like okay, I want to work in a team, and this is how I started doing more and more on the EWASM side, and and I finally like fully transitioned to that. And I mean the vision there was great. Like EVM, we all know has its quirks. It's good. Like now we accepted it, I guess. But it was always that we can do better. We can like it can be faster. This was one of the selling points of EWASM. You can write from multiple languages, so you can write Rust and compile it to WASM. This was a great selling point at the time. And it's just such a standard, right? Like you have WASM everywhere, you have it in the browser. There's great tooling for it. There's great interpreters for it. But as we like kind of started doing more research into it, we found out that okay, yes, it has these advantages, but actually you can make EVM quite fast. And this is when Pavel from Epsilon, he wrote an EVM interpreter called EVM1 that turned out to be just as fast as WASM. Um, and then it became a question like, okay, now if it's not much faster, then is it still worth it to switch? Because you have all these existing applications that are written in EVM and in Solidity. Um, and it's very, very hard somehow to transpile EVM to WASM. Uh, so it became this question, and like the team then started looking into other things, um, like phase one and done from Casey. Like these were the projects. Like this was before the merge, and this was the like ideas. Like okay, what happens after the merge? Are we gonna have sharding? Are we gonna have like identical shards? Are we gonna have execution engines? I believe execution extensions were called at the time. And so we started working on a WASM extension, like execution extension for Ethereum, so that in one of the shards you can have WASM. But yeah, like I was always I always cared about users, and this was kind of lacking for me. This feeling was not there that I'm having a direct impact on users. Like I can see it immediately. So this brought me then later on to Geth. And on that context, Mario, I so today in the morning I had an idea that maybe I can share. something with you guys, that I will prepare a presentation. And this is not a presentation that I've done before, so I had to do it from scratch. Um, I had a few meetings today, so it wasn't very successful. I've made a couple of slides. I'm happy to kind of start with that to give a structure. Um, and but you have to be warned because it's very raw and unfinished, and janky. So if you guys like, I can share the slides and we can
Let's do it.
Yeah, it
right.
seems like people are open to it. Like normally we never do this. This is just a chat. So I mean, if you
Okay.
want to have a test
I'm
audience,
happy to
go
stick
for it.
with your structure, but I just
Go for
um,
it. It's great. Yeah.
it's something that's been on my mind these days a lot. This topic, and um, so yeah, it's helping me personally think through these things. And so yeah, the topic that I want to share, like, well, let me first see how I can do this. Ah, okay, I have to allow sharing. Can you guys see my screen?
Yes.
Yep.
Perfect. Okay.
Interesting. Yeah.
Yeah, so um, this is a bit of a new topic for me, but it's something that I've been thinking about a lot. It's been on my mind, and it's basically seeing Ethereum clients from the lens of a product. We have all the software projects that we use. They are somehow also products, and they are placed in an ecosystem with users and competition, etc. So I'm trying to, in my head, map this ecosystem, um, and think about things like, okay, features, users, the alternative clients, and how they all tie together. Um, and I know this is the Ethereum Protocol Fellowship. I'm aware of that, and this might feel a bit adjacent to that. But I actually think it's very important for you guys because you guys are starting in your career of doing Ethereum development. Uh, I've seen the projects that you're working on. They are very exciting. They are very deep technical stuff, like implementing fossil, parallel execution, ZKVMs. All of these things are like very important things that we are working on, or you guys are working on. Um, I think it's important that while we are implementing these things, that we think that, okay, like these improvements that we're making, they are not improvements for the protocol's sake. In the end, the protocol is used by people. It's solving problems. Um, I want you to always keep this in the back of your head. What problem is this solving for who and how? Because we do have a history of sometimes shipping EIPs that don't gather a lot of usage. And I'm thinking of some of the pre-compiles, for example, but not necessarily. Um, and it does apply a lot to these protocols. For example, something that has been discussed for a long time within Ethereum research community is the concept of stateless clients. And stateless clients are great. It's a great idea. It allows you to sync a node like so fast. You wouldn't need a lot of resources like storage. You can basically almost immediately sync up to the head of the chain and then follow the chain. But I'm thinking of stateless here in a general concept, like be it vertical, but also a ZK verifying node that we'll have in future when we ship ZK on Ethereum. So in the like kind of general concept. Great. Now you can sync the chain and follow the head. What can you do with this node? I always had this question. Yes, this will be useful for some people like stakers, but if I cannot do any kind of transaction simulation, if I not process a new transaction that the user sends, or any of these things, then what exactly is it used for? So like it makes us think, what does this client, this stateless client or this ZK client need to do? What kind of features do we have to build in it? So this is the thing, like this is the context, this is the background. Now, like Ethereum itself, the protocol, it has, I think, it's offering a few different products. And I'm thinking of product in the very general sense. I'm not a technical product manager. I don't know the terminology here, but we are offering a few things. Like the first one is a block marketplace to end users. This is, they can submit the transactions to send money, for example. The second one is a blob marketplace to layer 2s mainly. So we are allowing layer 2s to gain from the security of the main chain by submitting these proofs and a summary of their state transition to the main chain. We have this deposit contract. It's kind of funny to think of it as a product, but I think it is, because it's a way for some people, stakers, to deposit their ETH and get some yield. So I think it's also kind of a product. You have EVM. Like this is, I think, one of perhaps Ethereum's most successful products, because it's been exported so wide and far. EVM is a product to contract developers and apps. Like the guys who are writing these contracts, they care about EVM, its details, what kind of opcodes are added, and so on. Like we need to basically keep them in mind when making any changes to the EVM, and we need to keep their pain points in mind and improve it accordingly. So Ethereum has an asset with sound economics, and for some people, this is a product. And in the end, Ethereum clients, they run the whole thing, the whole protocol and all of the above. But they are, or this is my argument, they are also a product for their users. But okay, so what's a product? I think that it's only a code base or protocol implementation. It's not only a code base or protocol implementation, but it's a living system that serves users, solve problems, competes in a market, and must sustain itself over time. And yeah, so from here on, I'm gonna focus specifically on clients as products. We don't like all these other things that I mentioned, where I'm not gonna get into them. I work on a client team, and this is the thing that I care about the most. So yeah, let's get into this. And by the way, this is going to be a short one because, yeah, as I said, I run out of time. But if at any time you want to ask a question, please feel free to interrupt. And yeah, so I think the most important lens to look at a client from a product point of view is its users. And yeah, it made me think of the famous Steve Ballmer meme: developers, 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 only users, users, users. I think it's the key. Like, as you know, also for Dev Connect this year, this is going to be the biggest focus. Like, we care about users. Same way with clients. We should care about your users. It's like we're not only an implementation of the protocol. Like Nimbus, Geth, Nelomite, like these are all products that people are using and depend on, and so we should be mindful of that. Here I want to actually open up and ask you guys, who do you think are the users of a client? And just let's collect a list. I want us to exhaust all the options, all everything that you can think of when it comes to users of a client. Who could they be? Any ideas?
I've heard institutional investors use clients to set up nodes.
Um, Mario, you want to say something?
I use client. I just want to use Ethereum, right? I mean, how
Yeah,
else do I use it without just looking into it, right?
yeah. I mean, so yeah, like people who are working on Ethereum, this one, Ethereum investors, I guess that they also use like run their own clients. Sometimes they somehow indirectly, either indirectly rely on a client, or directly run the node itself. Any other ideas?
Stay layer two.
Wallet.
Sorry, what's that?
Wallet.
Wallets. Yes, wallets are also, as far as I know, like mostly indirectly users of a client. I have a list in the next page, and we'll get to that. I put wallet with a question mark because they are somehow they are a user of the client. They're not directly usually running the client themselves.
But maybe with your previous idea with stateless, maybe like on smaller device, maybe it will be good for normal users, like not investors and something like that.
And this is a good question. Like, can we have the stateless client in such a way that it's embeddable in the wallet? And I think with the current idea, it's not sufficient. I'm happy to discuss this more because um, a stateless client does not have doesn't keep the whole state, and wallets need the state. They need to know the balance of the user. They need to know its history of transactions. So what has the user done in the last 5 years? What are all the token transfers they've done, and things like this. In the current form of stateless client, I think this is not possible. So we have to make changes to them to allow wallets to run an embedded stateless client.
I heard about execution witnesses, so I would like to hear your opinion after your slide about that.
Yeah. I mean, execution witnesses. So what they give you is basically the state that you need to run one block. But it can be that, let's say I have a wallet I haven't used in 5 years, and I want to transact with it now. How do I see the history? Like, how do I know what's the balance of this account if my node has never, like, in the execution witness, I can only see like since the node started syncing. So let's say I sync my node now and start receiving the execution witnesses. It doesn't touch my account because it wasn't used in the last blocks.
But
And
will you be able to prove the balance in a recent block so you kind of know the, the actual balance?
yeah, exactly. So you would need to receive a proof from someone, and who is that someone? So will you have to ask for a provider to give you this proof? Yes, probably. Like right now, it sounds like I will need to, like, the node is able to verify a proof because it knows the correct state root. So this is important. It knows the correct state root and it will be able to verify proof. The question is that, is it efficient enough? Because if I only want to know a transfer, then I can get a proof for my balance, and then I know I have enough balance to do the transfer. But if I want to do a Uniswap transaction, then it involves so many contracts and storage accesses. Like just downloading all of these proofs individually, yeah, it's a different story. especially because you don't know in advance all of the things that you will need. You need to start the transaction processing, and you will know first, like, okay, now I need the storage to be able to go further in the EVM execution. You have to request that, and then they will give you some data, and then you're like, okay, now I need this account, so you have to request another one. You cannot do batch retrieval even, and because of this, it's really not that efficient. But I think it's currently the only option, actually.
Thank you.
Yeah, any other users?
I think like RPCs and builders, RPC
Yeah.
providers, or
Yes. Actually, builders is a good point. I didn't include it in my list, so something that I can add now. Yeah, RPC providers like Infura Alchemy.
Layer 2s.
Yeah, layer 2 is a funny one. I also have it in my list as a not so straightforward case. I will get into it on the next slide. Okay, if there's no other ideas, I'm gonna show you here my list. And I have two categories: the more straightforward kind of users, the less straightforward kind of users. The first one is cypherpunk end users, and this I'm also including Mario in this list because he just wants to run his own node for interacting with Ethereum. For him, it's important. Then we have stakers. Funny, like nobody actually mentions stakers, but they're big use case category. Alchemy and Fura are like RPC providers. These guys are running nodes in scale. They have so many different kinds of nodes. They have different clients from Geth, Red, Nethermind. There are different combinations and many of them. Then you have Etherscan, Dune, the Graph. They are the, if I want to put a category name to them, it's the data indexers. They will extract all the visible blockchain data from the clients and make their own database from it, and then serve users with either UI or a query language. So another one is MEV hunters or MEV searchers, as mostly people call them. These guys also run, usually themselves, run clients, and they try to find opportunities. They try to test simulations using the client themselves. There's exchanges, so this goes somewhat to the enterprise investor that somebody mentioned. Like exchanges, I believe, run their own clients to be sure, and because they have to do a lot of operations like moving funds around and so on, and also knowing the head of the chain, the finalization points, and if I was running an exchange, I would not trust a RPC provider. Rather, I would run my own node. Now, the less straightforward kind of users, and the first one I have is layer 2s. And the reason why I mention it's like a bit less straightforward is that, yes, they are using the clients in a direct way in which they post their blobs. And like use it in the sense of a normal user by submitting transactions, right? So it's a normal transaction that has a blob that updates their main contract. But they're also, in a way, users of the clients because they are forking the L1 client, usually, not always. And so we have things like OP-Reth. We have Arbitrum Nitro. Well, actually, Nitro is not exactly like a fork of existing clients. It's one from scratch. But yeah, OP-Reth, OP-Geth, and Bohr from Polygon. It's also a fork of Geth. And Gnosis Nethermind. they are all basically forking the main clients, the like L1 clients, and they can be conceived of as users in some ways because they are consuming this product, the code at least. We have private networks so it's related to layer 2s, but yeah, private networks. This one is, I put the skull emoji here because at least in Geth, and I know in some other clients, it's a dead use case. We do not support private networks anymore directly and I mean like protocols like Click, because Click was a proof of authority protocol. So it allowed you to define a set of people who are authorized to make blocks. This is not supported anymore. We dropped support. Like Geth is a POS only client. And POS by definition is open, so it's permissionless. It's not private. Then we have projects that are using the client code as a library. So it's a bit of a difference there to how layer 2s use it. They just import our code and use it to run. So for example, if someone wants to do EVM execution, but they don't want to do it as part of the client or using it's called RPC, then they can import the REVM from Wrath and process a call using EVM. Wallets we have with a question mark, we already talked about this. And this last one, I don't know, I just had this thought, like GitHub contributors, because for us it's such an issue now. We have people on our GitHub who are literally like they only try to contribute somehow, which is super nice, but it can be anything, like sometimes not very meaningful PRs. So that I think their only goal is to farm commits and earn airdrops. But yeah, they are also somehow, we have to deal with them. They are also people that we have to deal with on a daily basis. And I kind of mention it now because it's a bit of a challenge for us. With AI, it's now super easy to spin up new PRs. So yeah, much easier to write the code than to review it. This is actually one of the biggest bottlenecks in Geth. It's the review capacity. Like writing code is much more easier than reviewing it. Not everyone can do that. So yeah, I hope that we can add builders to this list. I hope that kind of paints a picture of clients and who uses them, and as you can see, it's like a rich tapestry. Many different kinds with different needs. And so then the next question is, what are these people's needs? Like, what do they care about? And so I think that for the first kind, cypherpunk end users, they care about self-sovereignty. So they want to run their own thing, to be able to ensure that nobody is changing anything. You know that when you use the RPC provider like Alchemy, the result is not verifiable. They can, when you do an ETH call, they return you an answer like 5, and then you just have to take their word for it. But I definitely know users who run their own client just to know that it's correct. For these people, I assume that efficiency is also important, because as an end user, if I want to run a client, then I often don't have a big machine to do this on, or I would not want to spend a fortune to be able to run my own node. Before, it was possible to run Ethereum on your laptop. I've done this, in fact, but nowadays, yeah, it's a bit more tricky. For stakers, the most important thing is that they don't want to lose their stake. So it's very important that the client is implemented correctly. It follows the protocol, and that it's secure, so the key cannot be leaked somehow. When it comes to providers, they care about performance because they are running so many nodes. The heavier the node is, the higher their costs. So they're trying to these guys are low margin operators. So shaving anything from performance, then it gives them a bigger margin. The other important thing is spec compliance. This is something that providers often complain about because some clients implements this RPC method a bit differently to this other client, and they have to deal with this because they have to return the same thing to the user in the end. Data indexers, they, as I said before, so they run the client and to be able to extract everything they need from it in terms of data and then put it on a database somewhere. So they need, the speed of extraction, they need methods that allow them to do this as fast as possible. And they need features that support it. So they need detailed like trace abilities. They want to know exactly what happened in this transaction, which opcodes were executed. For map hunters, it's simulation features and mempool connectivity. They want to know as soon as a transaction appears in the mempool. So they often ask questions like, how can I increase the capacity of my mempool? How can I be connected to more peers so that they receive the pending transactions faster? And then they need features that allow them to analyze this transaction quickly and then see if they can find an opportunity in it. And they need it to be fast. So this is what they need. For exchanges, it's stability and security. Basically, they need something that doesn't change and secure as possible. They just need it to work. I have also some things for the less straightforward kind of users. So we have, I can think of something. So I can maybe try to give more examples so that it's not so dry. Wallets, they need API features. Something that we were discussing with wallets, for example, recently is that when they see, like when you're using an app and you try to do the transaction, then if you've noticed, then they try to simulate it and then show you what's going to happen. Like they can show you that you will transfer so much ether, you will transfer this token, like all of the consequences of your transaction. They try to show it in the wallet UI, which is super useful for the user, of course, but it's kind of tricky to do this actually using the current API. So we worked on something called ETH Simulate, which is, it's like ETH call but on steroids. It lets you simulate whole blocks and allow you to customize it a lot more. So we asked MetaMask, can you guys benefit from this? And they were like, yes, we definitely need this, but it doesn't solve one of the issues, which is gas estimation, because not only they need to simulate those transactions, but they also need to be able to estimate how much each of these takes in gas. And for that, they are using these super complicated API methods like tracing methods, and they run it so many times. Like when they showed me the code, it was horrible because they don't have a good way to kind of fulfill this need. So they need API features for one. Projects using client code as library, they need a stable API. They usually don't want the API to change a lot. They need backwards compatibility. And layer twos, like one of the things they need access to the teams, specifically when it comes to security issues. So we have a mailing list where some of these layer 2s are signed up, and when we see a security issue that can affect them, then we try to inform them. So for them, this is a need. Another one is they need often rollup specific features. So these are features that doesn't really benefit Ethereum users, but they need it, and it's a big question right now for like layer 1 clients, how to handle these kind of requests, because yeah, it will be code that we ourselves will not be using, so it's a bit more tricky. I know this was a bit dense. I want to give you guys a chance to ask if there's any questions while I drink a bit of a sip of water.
Okay, folks, the AMA part is finally here. Please ask if you have any thoughts. Nando.
Okay, thank you. I think the presentation is great. Just in this one, I think that all the users want some. Well, all the users follow the same. Some of there are features that are common to all the users, like efficiency, performance, and stability, for example. And the other, for the one you mentioned for the cypherpunks, for sure they want self sovereignty, staker security. So I think that you could say that everybody wants efficiency, security, and performance. On top of that, each of these one type of user wants some other.
Yes, 100% agree. I tried to bring the differentiating factor because I want to paint this picture that there are different users and they care about different things. But of course, if the client sync time is reduced, then everybody can benefit from it.
Yeah.
Like, if you can sync in 1 hour instead of 1 day, then yeah, what's not to like about that?
Yeah, but for example, in the stakers side, I think that all the stakers want to sync the fastest in less than a day.
I mean, I don't know about that. Why would you need to sync? Because you sync once and then you.
Well,
Yeah.
if you don't have redundancy and your node goes down, maybe you have to be fast.
Yeah, I mean, I am running a validator and I rarely have to touch it.
Yeah.
Luckily, yeah.
Mhm.
It can happen that on a occasion, like I might need to, if something goes wrong, then of course sync time will matter a lot because I might have to resync a node. But this happens very rarely for me. So I would say that as a staker, what I care most about is that I don't lose my funds. It's not slash. And you can say like performance maybe because it goes to the attestation rate. So I want to have a high attestation rate. And so it means that it needs to have a good performance as well.
Yeah.
Yeah, hi. I had a question. Like, this is the same like I had asked you on Twitter. So, like, with the state growth that's occurring, and let's say when we scale to let's say 400 million blocks, or like we increase the block limit, like ETH get logs or like something like ETH get proofs get stuck. So, like, what do you think would be the solution to that? Because like we are working on that. Like, we are trying to get a DevNet with 3 clients up for 7745. But like, how what do you think would be the good answer to state growth and also providing ETH get proofs for, let's say, a very high gas limit blocks?
I mean, this is the golden question. If you can answer this, then I think that state growth, you rightly mentioned that state growth is a big issue. ETH get proof is a big issue. I think that some of them are under investigated, or let's say now there is a big effort, the state plus effort to kind of find the bottlenecks And what happens when the state is quite large and larger? Mm, I don't have answer to that. I think that I just know that it's very important. We have a lot of different, like we hear it from different places because we always thought that it's something for the future. But what I can tell you guys that it's not for the future. It's here already, and we have to deal with it because we sat down with people from Base and with people from Arbitrum recently, and um, they are having big issues because their network, like they have such a high gas limit and such high demand. So the sizes of their nodes has exploded. I recently saw that Reth had to. So as you know, like Reth archive runs around 2 terabytes on mainnet, and they had a limit on their database size for 8 terabytes, and Base already broke that. So like Reth had to remove this limit of 8 terabytes because yeah, like the Base and WorldCoin nodes, they were already hitting that, and it's at least 4 times bigger than mainnet. And we also saw this with Geth nodes. So yeah, basically these guys were telling us that the Geth archive node on Base is more than 40 terabytes, and this is from a few months ago. I'm sure that it's above 50 now, maybe a bit more. And when you have sizes like that, first it's operation issue. So it's like, how the hell do you run at such a node and with a replication even? And then second is that it does a lot to the node performance. Like they were reporting that the node has slowed down. It's like sometimes it has these jumps in response time, and they need to run archive nodes because they need the proofs. So it's big. So I can tell you that from the guest side, how we're thinking about it is that for now we also implemented the alternative archive mode. So we call it the path-based archive mode, which is very lightweight. It's around 2 terabytes, and it can serve historical state, but not historical proof. But we know that a lot of people really need the proofs, get proof. So we are working on a feature that allows you to customize how long you keep the proofs for. So you can say that I need the proofs for the last month and customize your node so that it can keep the proofs for the last month. And with this approach, we think that it will become much easier to run these nodes, to run the archive nodes. It will require much less storage, and also it will help with the performance because how path-based archive works is that you don't keep everything in the key value database. So like, as you know, Geth has running on LevelDB or patch of LevelDB called PebbleDB. And this database, when it grows in size, then it becomes also slower because the underlying database uses a tree to index the keys. So what we do is basically in the path-based archive mode, we put the historical state and proof on a flat file, and it means that it can scale much better without losing performance. So yeah, this is something that we're working on right now. Like and we plan to test it soon in the next 2-3 months. How to solve state growth? Some variant of state expiry, I think. How it will look like, I don't know. Yes.
You mentioned that there is a better solution for the large data set, a better solution of the database for the large data set. I missed that part. Could you?
Yeah, so what I was saying that is that in Geth you have two databases, One is the key value database. This is keeping all of the states. And we have the freezer database. The freezer database is just a list of files, and it's very efficient. So it has O1 access, read and write. It's because it's append only. You just append to a file, and then there's an index that you can directly look up where to go to. So it's very fast. And we developed this for history. So basically for blocks, receipts, transactions, data like this. But it turns out that we can also use it for state history. So if you format previous states in terms of append-only structure, so per block state diff, if you format it like this, then you can use the freezer format, and it has O1 access, so it's faster. But I do want to mention here something, because there has been recently, like for the longest time, there was no big improvements in terms of the database. Now some teams are looking at this, and there was a while ago, there was a call about it. What was it? A month ago or so. But basically, what happens is that, trying to find. So I forgot this company's name, but anyway, they developed something called QMDB. It's efficient database. Well, it's more of a database, I think. It's like a state trie plus database. So it's really an alternative to the Merkle-Patricia tree. But if we do it, then it's like access to state will be much faster, and you can also do historical proofs. So it's a nice structure. But for that, you need to change it's a consensus change, right? So you need to change the trie format. And I think it's a much harder change. But what I'm excited about is that now, like, some teams started looking into implementing new databases, like key value databases. And this includes something called TriDB from base team. Let me see if I can find it. Yes, here. I can post it in the chat. So basically, did it work? No. I don't know why I can't see it in the chat. Anyhow, it's like GitHub base /TriDB. And it's a key value database that's kind of switchable from LevelDB. And it, as far as I know, I haven't looked into details of it, but it batches some leaves together and stores them in such a way that then access is more efficient, because in the end, when you look at it, like the leaves in the Ethereum trie, they are very small. So like for each account is, I think, around 60 or maybe with 80 bytes. And each storage leaf is 32 bytes. So they are super small. And if you manage to batch a few of them together, then it becomes you can have better locality caching. So a few relevant things together, it seems like they are getting basically some speed up. So like what I'm excited to see is like some experimentation done on these kind of new database formats, and we're starting to see some.
Yeah, thanks.
We are at a full hour here, so we should be slowly wrapping up. But I want to give you guys a chance to maybe ask more questions, or Sina, for you to finish.
It's okay. I don't have a lot more anyway. It's like not a lot. I think this is as far as I go. Yeah, sorry guys, this was a bit raw, this presentation. but I'm really glad that I could share it with you. But yeah, I mean, I'm here if you have some question for maybe another 5 minutes or so, but then I'd have to leave.
What are your intentions for this presentation? Are you intending to show it to guests, show it to the EF, present it generally on ACD? What's the intention here?
I think it was just a way for me to jot down these thoughts. It also ties together with something that I've been involved in recently, which is the ETH Client Summit. So my intention is or our intention is to bring together different Ethereum clients, like the client developers, and their users together. And I think that this is a forum that has not happened before, and I think it's quite important. Like, because right now you might not believe it, but the most common communication channel between client developers and their users is the GitHub issues and GitHub PRs, which is really, I think, low bandwidth. So yeah, we hope to have everybody in the same room around DevConnect in the DevConnect week. And yeah, because of this, I've been thinking a lot, like, okay, who are the users of clients? What are the needs? And what we want to surface is basically their pain points, like what are the issues they're facing. And I have a lot of examples right now just from conversations that I've been having with these users as I've been inviting them, which is, I think, very insightful for me, because a lot of these issues these guys are having, we didn't know about them. So yeah, I'm hoping that at some point I can maybe add some of their pain points to this presentation later on, and then share it somewhere.
Yeah, that's really cool. Thanks, Sina. Yeah. Um, Folks, do you have any thoughts? Let's use some extra space for maybe more questions um, about a presentation or get or anything. Ali?
I remember you also mentioned PebbleDB. I'm wondering what's that.
Oh, PebbleDB it's a key value database that is embedded. So it's written in Golang. We can use it as a library. This is the good thing about it. So if you think about other possible databases, like key value databases, like, I don't know, Redis or something, they are external. They have their own process. PebbleDB is something that is embedded in, like, it's a library you can use, and you just need to point it to a directory, and then it will keep its files and data. And yeah, the interface it has is like just get key, put key and value. Very simple. So it doesn't have a query language in this sense. And it's what actually most of the clients are using a database like this. It's just that some are using LevelDB, some are using MDXBX, and different implementations basically. But yeah.
Yeah, great. Thanks a lot.
Yeah. I guess something else I could mention is, like, PebbleDB was developed by the team by the team behind CockroachDB. So that's the parent company, and they developed PebbleDB to use it internally, and then they are also sharing it as open source so that we can also benefit from it.
Yeah, thank you. A lot of database backends there in the clients. Folks, do you have anything else that wasn't clear or you want to ask Sina before we wrap up? Um, I'm sure you will have a chance to meet Sina in Buenos Aires.
Yes, Also available on Telegram, Discord if you want to shoot a message. Happy to take questions. Anything around Geth or generally EL clients. All right.
Cool. Okay. I guess we can wrap it up here. So yeah, thank you so much, Sina. It was unexpected presentation, but it was great. Yeah. I'm glad that the fellows could have meet you and I'll learn something new. Definitely, very interesting point of view. We can chat about that more later. And well, in Argentina, looking forward to that.
Yep, I love that.
Awesome. So yeah, thank you so much for everyone, and I'm looking forward to continue this later. Have a great day. Thanks a lot.
Thanks for your time, guys. Bye bye.